Hello folks, this is part 2 of our Holocaust Memorial Representation, Eisenman's installation in Berlin. This video is going to cover height variation of each box based off of a curve attractor. Now, the distance of each box from the curve is going to determine its height. And at the end we'll plug in a color analysis to get a better visual representation of the height variation. So let's get started by inputting a curve into Grasshopper. Just draw it in Rhino with the curve command, and then go to the params tab and select curve, and right click, set one curve, and now it's defined in Grasshopper. So the tool we're going to use is curve CP, which basically defines the distance of the existing set of points from the curve. So we'll use that curve and our grid of points that we already have. And as you can see, the effect takes place. The curve and points are now related within these three functions. We're going to use the distance between base point and curve, which is d, and plug that into the z. Now as you see, the curve is definitely affecting the height of each box. Of course, that height is a little too large, so what we're going to do is multiply that distance, or each distance, by a specific number less than 1 to control it. So we'll multiply, take out multiplication, take out a slider, and we'll plug the slider into B and the distances into A, and then plug that into the height function. And there we have more of a controlled set of distances now, even less than that. And again, we're not accurately representing Eisenman's installation. We're just sort of going over the logic of, this dynamic flow of boxes. So if you look near the curve, these boxes are at an unreasonable height, unusable height. So what we need to do is set a minimum or maximum number that a height can be. So take out a maximum button, copy the slider over, and we'll set that max to 0.5, and we'll plug that into each distance, and then plug that into the z. And if you see, there's no height less than 0.5 right now. And then you can further manipulate the heights. You can move the curve around, and each box will be affected. Move that towards the center, you get this sort of flow towards the center. Move it towards the outside, and it's this sort of seating arrangement. So for a color analysis, we need a gradient, which is in the special tab under the params tab, and also we need a way to preview that gradient, which is under custom preview under the same tab. Now L0 is the colors on the far left, and L1 is the colors on the far right, and T is going to be the defining parameters. So we'll plug the distances into T, and then we'll preview that in S, and G asks for the geometry in which the preview is going to be applied to. So we'll unpreview the caps. So there we go. The further away the box is from the curve, not only is the height greater, but the color is also darker because of this set gradient. We can change that under the presets to get a clearer preview. Again, move this curve around, and dynamically, visually, it's all controlled parametrically. Alright, so let's say you wanted to have two curves affect the height of each box, what you do is you use this same process right here, but you the additional step you would do is add both maxes that you would have and then plug that into the Z. Alright, well, thanks for watching. Subscribe for updates. You can visit my blog at emergestudio.com. Video 3, the final video on the Eisenman installation, is going to talk about image sampling and how the height variation is going to be determined by the pixels of an image opposed to the curve attractor. So thanks again for watching.